Knowing this, we can find the time it takes for the ball to fall this vertical distance. Using the displacement equation, we can fill in the displacement as negative 18.47 meters, which is what you just found, except negative because the ball is falling beneath its initial point. The initial velocity as negative 24.45 meters per second, and the acceleration as negative 9.8 meters per second squared. So we can solve for our variable, time, using algebra. You should get a quadratic equation, and then make sure you use the quadratic formula to get two values. You will get two answers, but only your positive can be used for time, since time can never be negative. So after this quick calculation, we get the time from the top of the cliff to the car's roof to be 0.67 seconds. And just to point out, the number I used for the result of this value right here was not the exact number with all the decimals. Instead, I took it and rounded it to the hundredths place. So it might be different if you just take the answer you get from your calculator and copy and paste it into the next calculation, since I did round. So nothing major, just a slight difference, if anything. So now we need to find the total time from the initial throw to the time the ball hits the car, which can be simply found by adding 4.99 seconds of the ball above the cliff to the 0.67 seconds found of the ball below the cliff. So in the end, this is 5.65 seconds of total time. So finally, we can use this information to answer one of the questions the problem asks, which is the distance the ball travels until it hits the car. To find this, we can actually use the information of the horizontal path of the ball in the displacement equation. We can fill in 5.20 meters per second as the initial velocity, 5.65 seconds as the total time that we found just a second ago, and we can cross off the whole second part of the equation, because if the acceleration is 0 meters per second squared, since the acceleration is 0 because the velocity does not change, there's no additional forces on the ball side to side, then the whole second part multiplies to equal 0. Finally, using unit analysis, the horizontal displacement is found to be 29.38 meters, which is the distance the ball traveled until it hit the car. So that actually answers one of the two questions that we are posed in the initial problem, so now we only have to tackle the second one. We can begin to work on the question of how long the car must have waited before driving towards the cliff now. To do this, we have to find the distance the car had to travel to reach the point when it was hit by the ball. Since we know that the gas station at which it started was 90 meters away from the cliff, and the collision of the car and the ball occurred at 29.38 meters from the cliff, we can find the distance the car traveled using 90 meters minus 29.38 meters, which calculates to be 60.62 meters. So this is actually the final stretch of the problem, in which we answer the question about how long the car must have waited before driving towards the cliff. First, though, since we know the distance it traveled to be 60.62 meters, we must find how long it took the car to get there. So 0 meters per second is the initial velocity since the car started at rest, and that means the first part of the displacement equation is eliminated. The acceleration is known to be constant of 4 meters per second squared, which we were given in the problem, and then we can find the time the car traveled to be 5.51 seconds. So last part, to find how long the car must have waited after the ball was thrown until it started driving, we can simply subtract the time the car traveled, which we just found to be 5.51 seconds, from the total time the ball traveled, which is 5.65 seconds. So this would be, if we put it into the equation, 5.65 seconds minus 5.51 seconds. And this yields a time of 0.14 seconds, meaning that the car waited 0.14 seconds after the ball was tossed before its driver hit the pedal. So that's it. You have answered all the questions, and these are the answers written again, just in case. Overall, I think this problem can be solved using a thorough diagram and by separating the information into smaller, simpler parts, because it may seem overwhelming at first.